Taking a clue from the first video, we will first search for a cyclic quadrilateral. So search for a cyclic quadrilateral, and that's actually pretty easy to find. See, this particular angle, that is angle REB, is 90 degree, and that's because R is the intersection point of the diagonals and E is the midpoint of the rectangle's side, so certainly it's a 90 degree. You can prove it rigorously. And angle RFB is 90 degree by the given data. So these two are right angles, so they certainly add up to 180 degree. And as I mentioned in the previous discussion, that if the opposite angles of a quadrilateral add up to 180 degree, then it's a cyclic quadrilateral. So basically we can draw a circle passing through 4 vertices of this quadrilateral. Okay, now we will use another property of a cyclic quadrilateral, that is angles subtended by the same arc, in this case arc ER. So the angles subtended by ER at the circumference are these two angles. Those two angles are equal. That's a property of cyclic quadrilaterals again, that angles subtended by an arc at the circumference are certainly equal. Okay, so that would mean if this angle is theta, then this one is also theta. So we have some additional information that angle EBR is equal to angle EFR, and we assume that both of them are theta. In fact, we can easily say that angle RAB is also theta, that is this angle. Why is that? Why is this angle theta? Because ABR, this particular triangle, ABR, this triangle is an isosceles triangle. These two angles are equal, these two sides are equal because diagonals of a rectangle are equal and they bisect each other. So we have plenty of same angles in the picture, but one final one will actually create the trick. So this angle here, angle RES, you can also show that this angle is theta. But why? As a clue, I'll say just look at the triangle REB. It's a right angle triangle because angle E is a right angle. So let me draw it separately here. So REB, it's a right angle triangle, and we have dropped as if a perpendicular ES. So this is 90, this is 90. If this angle is theta, then you can easily show that this angle is also theta. So this little geometry will actually solve the problem totally. So I'll leave this particular video at this point. Take it as a hint. If you cannot do it, then go back to the link in the description for the third video in this sequence.